This is our Math 0232, Lesson 3B. In the next preview assignment and in the next class, you'll need to be able to use rates and unit rates. So I want to underline a couple of thoughts. Do follow along. Make sure that you have this printed out or that you have it up on your computer electronically to make your notations. In the next preview, you'll be able to use rates and unit rates. In addition, you're going to need to be able to calculate the mean of a data set. A rate. So however you are keeping your notes, whether it's using highlighters, sticky notes, index cards, whatever you've got going on, you need to know when someone says rate, what are they talking about? So a quick definition is it's a special ratio in which the two terms are in different units. And so you got to make sure that you know what a ratio is, and you got to pick up on the word different. I want to hone in on the word different. I'll let you go back and remember what we've talked about on ratio, what you've heard before, or search the internet for ideas. But I want to hone in on different. A rate has different units. And I'll keep reading. My brain goes straight though to miles per hour. So it's written as a ratio and it has different units. We have miles in the numerator and hours in the denominator, but the lesson says when the denominator has a value of 1, whoops, we're moving on, then it is called a unit rate. So we're going to be calculating something for just 1 unit. So typically the keyword per is used, like when we say miles per hour, miles per gallon. So whatever you need to do to underline, highlight, get these pieces to make sense to you, go ahead and make that notation. The example that they give for a rate, let me get my pen back up here, is if we are traveling 60 miles in 3 hours. And then it talks about the unit rate could be created when we do a little bit of conversion so that the denominator is 0. One thing I think you should make sure you do in this lesson and the whole semester is to write what you're thinking. Try to help clear up any, I call it weird stuff, make your brain behave. In other words, I'm going to jot down 60 miles and make sure I know what I'm talking about if I put MI or go ahead and write it all out per 3 hours. And so I've now written it as a rate, 60 miles per 3 hours. And then they ask a little bit more like, okay, well, what about a unit rate? And so a unit rate, I'm still going to have miles in the numerator, an hour is what's going to end up in the denominator. Then I grab my calculator and I need to make sure I make my calculator behave. And then I type this in correctly, that I do 60 divided by 3. So cutting my calculator on, I'll do 60 divided by 3. However, it's always good to do mental math and like do 6 divided by 3 and I get a 2, but I didn't do anything with that 0. So I've got 20 miles for every 1 hour. So we have a rate and we have a unit rate because it now has a 1 in the denominator. So make sure that this is making sense. Stop right here and soak it in, or talk to some people around you, or call them or text them, but mull over this till it's making sense. What is a rate and what is a unit rate? Even to ask for examples from people around you. Hey, what are some rates? They may not know, but give them an example of 30 miles for 3 hours or 20 miles per hour. And they'll probably say, oh yeah, like, miles per gallon or something like that. Well, we have some activities here on number 1. We have part A, B, and C. So I'll do part A. And it says a person drove 900 miles in 12 hours. I think it's really good that you always underline your information, highlight it, do something so that your brain focuses that I've got 900 miles, 12 hours. And then the question is, how many miles per hour they drive? Again, I don't think you can write down too much, miles per hour. And then I start filling in. Well, I was given 900 miles and I need to go divide, have that over 12 hours And so they want us to write each of the following as a fraction and then convert it to a unit rate. Always go back and read your directions and then write a contextual sentence using the unit rate. So I have a fraction, check, I did the first part. So unit rate, I either need to do some mental math or I'm going to grab my calculator, start top to bottom and do 900 divided by 12 and I get 75. I need to make sure I have good units, good numbers, and that's over 1 hour, 75 miles per hour. So having said that, the unit rate is done. The written as a fraction is done. The only thing I haven't done is to write a contextual sentence. And so I can go as elaborate or as simple as I want to over here. You can use your name, friends' names, somebody's name you just heard called in the restaurant, whatever you want to do. You could also just use a pronoun. They were driving 75 miles per hour. And you might even write it as this, 75 miles per hour. We're going to move on, except what I'd like you to do is to pause the recording. I'd like you to do part B by yourself and then come back and check to see if you and I match, if there's a mistake on my side or a mistake on your side, and help to figure out what's going on. Again, it asks us to do a fraction in a unit rate. A pie, 4,800 calories. We're going to cut it into 8 slices. How many calories are in each slice? So they're wanting to know how many calories per slice. So I'm going to go grab my calories number, and I've got 4,800 calories. I've got 8 slices, and I either do some mental math or grab my calculator, but I know that 48 divided by 8 is 6. I didn't mess with those zeros. So 600 calories per one slice. Always keep bouncing back and forth between where you are and what we're supposed to have. It said write it as a fraction. Yes. It said write it as a unit rate. Yes. And then it said write a contextual sentence. And again, you can use the name of yourself, somebody around you, one of your kids, one of your pets' names. You can make it as elaborate of a sentence as you want or as not. And so you can just simply say each slice of pie has 600 calories. Yes, yes, it does. And so we're going to finish up, and I'd ask you to do the same thing. I'd look at how well you did on part B, see if you need to make any adjustments, go back and regroup, look at stuff, maybe even come back up here and review some of the material. And then do C first by hitting pause on the recording and then calculating it and then coming back to see if we match. So part C says we've got a 6-liter bottle, water, cost. How much does the water cost per liter? So they're wanting to know cost per liter. Again, and maybe for the last time this time, just to say, write information down or your brain's going to flip it. Your brain is going to switch it around. Your brain's going to do weird stuff. So make your brain behave that they want cost per liter. So the cost represented in this problem is $6.99. How many liters are represented? Well, it's giving us a 6-liter bottle. So I'm grabbing my calculator, and on my calculator, I'm going to do 6.99 and divide it by 6. So I get an answer of 1.165. I'm also going to think on that this is about $7, but if it was about $6 divided by 6, I'd need to get an answer somewhere in the neighborhood of $1. And I did. I got about-ish, 1-ish. But I go back and read the directions, and it says to the nearest cent. So I have $1, and the 6 needs to look at the 5. The 5 says, yep, you're going to go up. So it's going to be $1.17. And we're supposed to write another contextual sentence. Again, you can make it as elaborate or as little, change it up or not. But the fact is, a sentence could be the water cost $1.17 per liter. Now going on to question number 2, it's great if you want to go ahead and hit pause and go ahead and work on part 2A, or go ahead and do part 2B. You decide how you want to do this. Maybe you want to watch us do part A and then do part B by yourself. But here's part A. I need to read the directions. You can use unit rates. And if you're still thinking, what are unit rates? Then go back and make sure you've got it on a flashcard or something where it's like, oh yeah, unit rate. That's the one that has 1 in the denominator. But they want us to use those to compare prices. And maybe you've noticed before, like the labels in grocery stores, they'll have like the per ounce, the price per ounce. And so that's all we're doing right now. And a lot of times they've done it for us. And sometimes I double check them just to see if they were right. And compare the prices and find the best values. Find the 2 unit rates for each situation and use them to determine which value is better, and then write another sentence, just a very simple sentence. So we are comparing values. So we need to know what's the price per, and in this case, we're looking at ounces. So we have a bag of Cheetos and we need it price per ounce. So there's one of them. It's going to be about-ish, something-ish. And then this other one is a 12.5-ounce bag, and it is $4.29. And that's going to get us an about amount. So here we go. I'm going to grab my calculator. I'm going to make sure I'm dividing top to bottom. I grabbed my phone, trying to cut that on. No, here we go. $4.99 divided by 20 5/10 ounces. And I'm getting about 0.2434 for every 1 ounce. So about 24 cents for this first one. The next one is $4.29 divided by 12.5 ounces. And I'm getting about $3.432 per 1 ounce. So about 34 cents for an ounce. And so in the long run, we would save money if we bought the one that cost us less per ounce. So we did change them both unit rates. We have made a comparison. Over here is the winner. And then a quick sentence. The 20.5 ounce bag of Cheetos cost $4.99, while the 12.5 ounce bag costs $4.29. That's too long. I don't need to do that. The 20.5 ounce bag is a better deal because it is priced at 24 cents per ounce, while the smaller bag costs 34 cents per ounce. Just something, it's just asking us to justify our answer. And so you can talk about one, you can talk about the other, you can make it really verbose, or you can get straight to the point, but don't make it too short. Go ahead and make it where it makes sense that the $4.99 bag was about 24 cents an ounce. The $4.29 bag, I think I said 99 and 29, was about 34 cents. So the better value, the better deal, the one that I would choose to buy is, and just make it a very kind of short explanatory sentence. So I am going to move on to the next one, but again, I encourage you to cut off the video and you do part B all by yourself and then come back and we'll talk about it together. Again, if we're looking for the best deal, we're looking for money per, in this case, it's going to be soap bar. And so the first one is $10 per 12 bars. That's going to get us some amount. The other one is $4 per every 5 bars. You can even play games with it and make guesses and talk to people in the room and say, which one do you think is going to be better? I'm going to go ahead and divide 10 and divide it by 12. And I'm going to get about-ish 83 cents. The 3 is going to go on and on and on and on for every bar. I'm converting to a unit rate. And then my other is $4 divided by 5. And in this case, I'm getting about, I know exactly, 80 cents for each one bar. So having said that, I now need to write a contextual sentence. So if you didn't stop the computing, or if you did and something's not matching up, go ahead and stop the video and compare, look at how am I doing? How are you doing? But look at the answers and let's do a summary here. It's 83 cents a bar if you buy the package of 12, and it's 80 cents if you buy the package of 5. And so there are other factors that influence why we buy what we buy or not. And in this case, if we're looking for the best value is going to be this one. And so write some kind of a sentence that says it's the best value. And again, you can write a whole lot. You can be really verbose. You can keep it kind of simple. Just don't keep it too short. Blah, blah, blah. Where are we? 5 bars. There it is. The 5-bar package is a better deal because it's priced at 80 cents per bar, while the larger package cost 83 cents per bar. Yay, we're done with that one. So we're moving on to number 3. It would be good for you to go ahead and read on number 3, hit the recording, make it stop, and then I'll see you right back as we start to talk about part number 3. So the last thing that we're asked to do in this lesson is we are asked, or told, I should say, let me just read the directions. Unit rates are also useful for when finding averages. So now we're going to combine a couple of concepts, unit rates and our knowledge of how to calculate an average. Each item in the list must be in terms of the same unit rate. So I probably should figure out how to highlight here because this is huge. Each item in the list must be in terms of the same unit rate before computing the average. You don't want to do what they say, apples to oranges. You want to compute apples to apples or oranges to oranges. So the following is a list of 4 brands of bottled water and their price per liter. And so I need to be slow, methodical, intentional. So all of these are 1 liter. Okay, but over here, it either mentions cents or it puts the cents in terms of dollars. So here's dollars. They didn't even tell us this one. It would be 119 cents. Cents, dollars, cents, dollars. So it does not matter how you calculate this, either using all the dollars or all of the cents. You just can't use like a cents and combine it with the dollars. That's where you're going to get wrong information in your calculations. So it says, what units do you find most convenient for the unit rates of these 4 brands of water? Well, that's your opinion. Which one do you like? Which one do you think is better, nicer, whatever? I'm going to lean towards the dollar. We could either do dollar per liter or we could do cents per liter. I feel like there's a lot of confusion around the cents. And every time I'm in a store, I look and I want to be a smart aleck and go up and say, okay, give that thing to me for less than a penny. I saw something the other day that said this. And so 75 hundredths of a cent means it is less than 1 penny. I know what they meant. They meant that it was 75 cents. But when you use this decimal and that cent sign, you just told us it's less than a penny. And I want to go plop down a penny and say, give me that item and then give me change for my penny because it didn't cost a full penny. Anyway, soapbox over on that one. Let's go back over here. What units? I'm probably going to prefer to stick with dollars just because there are usually a lot more mistakes using just cents. And so then it says, once you've decided whichever one you want, let's find the average cost per liter. Since I am recording this, I'll go ahead and do both. I'm going to do my way first. Like I want to take my 59 cents because I'm looking for an average, and I need to add it to $1.19. And see, that's what's so confusing. I'm saying cents, but it's a dollar symbol. It's cents written as a dollar. And so here is 99 cents, and here is 69 cents. So grabbing calculator, I'm going to add all of these up, cut the calculator on, 0.59 plus 1.19 plus 0.99 plus 0.69, and I get $3.46. Okay, but they want an average. So I've added them all up, and now an average means you divide by the N. The N, how many things are there? Well, how many things are there? I've got 1, 2, 3, 4. So I divide it by 4. I've left this on my calculator so that when I do divide by 4, I get 0.865, and it says round to the nearest cent. So it's this for every one. We just found an average, which looks like a unit rate. And if they want it to the nearest cent, then I've got to look, if this is cent, I got to look behind it, the thousandths, and that 5 tells my 6, you got to go up 1. And I like writing it with a 0, a leading 0. You don't have to, I just think it looks better. The scribble doesn't look better. And so finally it says, find the average cost. I'm going to go ahead and write it as a unit rate. It's 87 cents for every 1 liter is the average of these 4 bottles when I do this information in dollars. I'm going to go ahead and go back and do this in cents. And this would be a great time for you to stop the video and go calculate it yourself in cents. But oh, that's not a very dark color. Let's try pink. I'm going to try 59 cents and 119 cents with my 99, you get the idea, cents, and 69 cents. And when I add those up, because I'm now going at this again to do the average using just cents, not written as dollars, I've got 59 plus 119 plus 99 plus 69. And it helps my brain to think these would look like pennies. They would look like a cent. They look like pennies. And when I do, I get 346 pennies. And so I can write that 346 cents. But remember, I'm trying to find an average. And it's 346 cents for all 4 of them put together. So I need to divide off, get it into singles. And when I do, I get 86.5. So over here, I would write 86.5 cents for every 1 liter. Now, it said round to the nearest cent. I'm still in a decimal, can't be my final answer. That 5 makes that 6 go up. So it's 87 cents for every 1 liter, which that's exactly what we've got over here. Just one's written as a penny and the other one's written in terms of dollars. So the last thing I would like to share with you is where this question number 3 is going. It doesn't ask me to write a sentence, but I'm going to go ahead and state a sentence that the average, where is it? The average cost per liter for these 4 brands of water is 87 cents per liter, or you could write it like this, 87 cents per liter. And the last thing I'd like to leave you with is where we're going with this number 3. Unit rates relate to what's called a central limit theorem that we will explore in preview assignment 3B. In this assignment, we will look at the average diameters of peas for larger and larger sample sizes. These averages are like unit rates, like the length of the diameter for each pea. For each sample size, there is a different unit rate. For example, If someone has a bowl of peas and finds the average diameter for a sample of 3 peas, then every sample of 3 will have a different answer. The central limit theorem indicates that if we were to plot, here's the crux of the matter, if we were to plot a histogram for the averages from all of the possible samples of a given size, as that gets larger, the histogram is going to start to look like a bell curve, and that's going to be very, 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 very cool. This concludes our lesson 3B.